Hello PLP Geometry, and welcome to the beginning of the last unit of this geometry course, Unit 7. So we have two kind of topics we're pairing together in Unit 7. The first topic is 3D geometry, and the second topic is probability. Okay, so again, the state sprinkles a little bit of probability and statistics into each math class you take. So again, the probability will be a short little piece, but the 3D geometry will be a couple lessons long. So this first lesson here, I'm going to break it into two videos. So this is lesson 1A. Again, we're covering in this first lesson cross sections and solids of revolution. Now, in this first video, I'm just going to kind of give you the background information on 3D geometry, and then the second video will get into cross sections and solids of revolution. So, 3D geometry involves what are called polyhedrons. Polyhedron. So, a polyhedron is a 3D figure whose faces are polygons. So when I say the word faces, right, I mean the planes or the 2D shapes that make the polyhedron up. So for instance, if you think of a box has 6 faces, right? The top and bottom, the left and right, the back and front, right? So those are the faces. And again, they're going to be polygons, which means they have segments connecting them. Okay. Now, we will also involve 3D figures that involve circular parts too. And that's actually a big part of our geometry course, comparing it from middle school to up here, right, is the 3D with circles. So our first type of polyhedron would be called a prism. And a prism is a polyhedron. And again, we're going to also talk about circles, or the circular prism, so be aware, but polyhedron with 2 congruent and parallel bases. 2 congruent and parallel bases. Now, there are other faces in this polyhedron other than the bases, and those faces are called the lateral faces. So in a polyhedron, the lateral faces are rectangles. So the lateral faces are rectangles. So we're going to talk about 3 types of prisms here. So the first one's going to be a triangular prism. So to draw a triangular prism, I'm going to draw 2 triangles that are going to be congruent. So I'm going to draw one towards the front. Give me a second. Okay, so draw one towards the front, and then I'll draw one towards the back, kind of offset, right? And now what I'll do is I'll connect the corresponding vertices. So I'll connect the tops. I'll connect the rights, and now the lefts are actually going to be kind of dotted because they're actually behind the figure from my perspective. And there's your triangular prism. Triangular prism. Again, it's called triangular because the bases here and here are those congruent triangles. And then if you notice here, right, if I do this in maybe pink, this face right here, that is one of the lateral faces. That is a rectangle. So that is why in a prism, the bases are the shape of the base, and then the other sides are rectangles, the lateral faces. Okay, let's do a rectangular prism. So now I'll draw a rectangle in front. I'll draw a rectangle congruent to that rectangle back, and again, I'll connect corresponding vertices. So the top left, the top right, the bottom right, and again, the bottom left I'll make dotted. So now again, this is a rectangular prism. Now, a special type of rectangular prism could also be a cube. For a cube, remember, a cube is just made up of all squares. Okay, so that's a special type. But again, in this rectangular prism, the front and the back rectangle are my bases. It could be the bottom and top, whatever you want to do. And then again, all the other faces are also rectangles. Now notice this one looks like a parallelogram because it's kind of angled. But again, it's just because you're doing 3D on 2D. Okay, and then last but not least, a cylinder. So a cylinder has circular bases. So I'll do the top and the bottom will be circles. And now I'll just connect the sides. Now if you want to be perfectly accurate, right? So I'm going to take this bottom base and make the back part dashed. Okay, so again, you won't see the back part of that base. So here is a cylinder. I'll put the word cylinder up top here. And again, when you think of cylinder, think of circle, right? This is one of our 3D shapes that involves circles. So the bases are the circles. And what happens is if you take that, the wrap, I would say. So if you think of a can of soup, like the label is the wrap around it, and you were to unwrap that and fold it flat, it would be a rectangle. Okay? We're not going to talk about surface area, but if we did, we would really mention that. Again, cylinders, the circular shapes are very important to the state tests, so let's try to remember those. So there's our prism talk. Okay? Next. Okay, now let's talk about pyramids. So again, right, if you think of the Egyptian pyramids, that's exactly what we're talking about. So pyramids. So a pyramid is a polyhedron with one base. And again, in this case, the lateral faces, so your lateral faces are triangles. And the reason the lateral faces are triangles now is because if it only has one base, then the other side, whatever you want to say, other direction of the polyhedron comes to a point. Okay? So let's start with our triangular pyramid. So I'm going to draw a triangular base, just like this. Okay? And I'm going to put a point. And I'll just do it right up top in the middle. Okay, and now we're going to connect all three corners of the triangle to that top. So I'm going to make the outside solid, so like there in the front. And then I'll make the back one dotted. So it's like sort of the back. Now a triangular prism is hard to see, okay? Or a triangular pyramid, right? But it is there. So this is a triangular pyramid. Triangular, sorry about that, triangular pyramid. Okay, now again, in this picture, the base, that triangle is shaded. And now if you look at the lateral faces, so if I take if I highlight this guy, right? 1, 2, 3 sides, he is a triangle. So that's why all the other faces are triangles. Okay? All right, let's do a rectangular pyramid. And again, it could be a square pyramid too, but I'll do a rectangular pyramid. So let me draw a rectangle. And again, that could be a square. Let me put the point right at the top. And now let me connect. So I'll let these front ones be solid. Right? These backside ones be solid. Which means that if you want to be completely accurate, this back segment of the base is going to be dotted because you don't really see it. Right? And again, it's hard to do 2D or 3D and 2D. We just do our best. Right? So again, this is called a rectangular pyramid. But again, I'll put the word square in parentheses because it could be a square. Okay, so again, the shape of the base is that pyramid. And now if I take a look at the lateral faces, just this one in front here, that is a triangle. Okay, and last one is going to be a cone. I'm going to put the circle I'll put the circle right down here. I don't know why I did it backwards in my own notes. And here's the point. Maybe I wanted to do like an ice cream cone, right? This is more like a traffic cone. Okay, so there we go. All right. Again, if you want to be completely accurate, right, you should make the back, because you won't see that back. Okay, and again, if we look here at this cone, and again, when you think of cone, think of circle. So we have the base is this circle, and again, if you unwrap what goes around, it's estimated to be like a triangle. It really isn't a triangle because it's curved, but we estimate it to be a triangle, and that is what the lateral face comes out to be. Okay, so we talked about prisms, we talked about pyramids. The last 3D shape that we must mention is a sphere. So a sphere is the set of all points in space equidistant. And again, when it's equidistant with a sphere, just like a circle, that's the radius length, equidistant, which is the radius, from a given point. And that's going to be the center of the sphere. So how we draw a sphere, just like if I was going to draw like a beach ball. So here's my circle I'm going to start with. There's my center. So I'm going to draw what are called great circles. So these are two circles. They're going to be kind of angled, so they look more like eggs, I guess. When I go across the front, it's going to be solid. But when I go in the back, it's going to be dotted. So that creates that kind of 3D width there. And if you want to do one vertically too, you can do that as well. And that creates that 3D look of a sphere. And again, it is the cylinder, cone, and sphere that we're really going to focus on. Okay, so this was the background video. I'm going to do the second video where we actually talk about cross sections and solid revolutions coming up next.